Hey everyone, welcome to Neural Notes, show where AI comes alive. Smash that subscribe button and ride the innovation wave.
Hello, students. In this episode of Neural Notes, we'll witness the fall of a psychological empire and the birth of a revolution that gave us a new way to understand the mind. You know, for almost half a century, one single idea pretty much ruled American psychology. But then, in the 1950s and 60s, a few intellectual tremors started to shake its very foundations. This led to a complete shift in how we study, well, the most complex thing in the known universe, the human mind. Okay, let's dive into this. So, before the revolution, the dominant force was behaviorism. The main idea here was that psychology should only study things you can see and measure, observable behavior. The mind itself, thoughts, feelings, consciousness, that was considered a black box. It was seen as totally unknowable and frankly unscientific. The thinking was, everything we do is just a response to our environment. Simple as that.
And the main guy behind this, B.F. Skinner, he really ran with this idea. He argued that even our most amazing abilities, like language, aren't coming from some deep internal mental process. Nope. For him, language is just verbal behavior. It's something shaped entirely by our experiences, by rewards and punishments, just like a rat learning to press a lever for a food pellet.
But then, a linguist named Noam Chomsky comes onto the scene, and he throws a wrench in the works with a challenge that behaviorism just couldn't answer. He took a hard look at language, this supposedly simple verbal behavior, and he found something that conditioning alone just couldn't explain, not by a long shot. So here's the core disagreement right here. Skinner saw the mind as a blank slate, and experience just writes the script for language. But Chomsky, he argued the total opposite. He said, no way, we must be born with some kind of built-in mental framework, some kind of language acquisition device that gives us this incredible natural gift for grammar.
Chomsky's big weapon in this debate was called the poverty of the stimulus argument. It sounds academic, I know, but the idea is actually super powerful. He basically said, just look at the language a child actually hears, the stimulus. It's messy, it's incomplete, it's full of mistakes. And yet, somehow, from this jumbled input, kids develop this incredibly rich and systematic understanding of grammar. So how is that even possible?
Let's break this down a bit. Think about it. Children don't just parrot things back. They create totally new sentences they've never, ever heard before. They master these super complex rules without anyone sitting them down for a grammar lesson. And they just instinctively know not to make certain kinds of errors that might seem logical. The input they get is just too poor to explain the sophisticated stuff they produce. For Chomsky, the only possible conclusion was that something has to be innate. It has to be built in.
So, Chomsky's argument was the first major crack in the foundation of behaviorism. But the thing that really gave psychologists a new way to move forward was a totally different kind of revolution happening at the same time, the dawn of the digital computer.
And all of a sudden, there was this powerful new metaphor for the mind. I mean, for decades, it was forbidden to even talk about mental processes. But the computer, well, it gave them a physical model. It takes in information, it processes that information based on a set of rules, and then it produces an output. And researchers started to wonder, what if the mind works just like that? And this thinking led to a brand new framework, the information processing model. And it's just beautifully simple. You've got information coming in from the world through your senses, that's the input. Then the mind does a bunch of stuff to that information, that's the process. And finally, that results in some kind of behavior, the output. The black box was finally being pried open. This new model totally changed the game. It posed a brand new fundamental question for the entire field of psychology, right? If the mind really is an information processor, then what is a psychologist supposed to be doing all day?
And here's the answer. The new mission for what would become cognitive psychology was to try and reverse engineer the mind's software. Your job was to figure out all the hidden mental steps, the algorithms, the program that our brain is running to turn any given input into a specific output.
So, armed with this new perspective, a whole generation of pioneers could finally start to explore that unseen territory of the mind. They started tackling huge concepts like attention and memory. One of those pioneers was a guy named Donald Broadbent. He was completely fascinated by attention, our ability to focus on one thing in a noisy room while tuning everything else out. And using this new information processing approach, he came up with a way to actually model this invisible mental process.
What's so brilliant about this model is how it lets you visualize what's happening inside.
Broadbent suggested that all this sensory info comes into our system, but it immediately hits a kind of bottleneck, or a filter. This filter picks just one stream of information to let through for deeper processing, and it blocks out all the rest. He wasn't just watching behavior, he was actually drawing a map of the specific steps happening inside the mind. Then you have another pioneer, Saul Sternberg, who applied the exact same kind of thinking to memory. He wanted to know what's actually going on when we try to pull a piece of information out of our memory. What are the mental steps involved? So he came up with this really clever, simple task. He'd have people memorize a short list of numbers. Then he'd flash another number on a screen and measure exactly how long it took them to say, yes, that was in the set, or no, it wasn't. And based on how their reaction times changed, he proposed this step-by-step model. You perceive the number, then you mentally scan through your memorized list, one item at a time, making a comparison for each one. It's another perfect example of trying to map out the mind's internal program.
So what's the lasting impact of this cognitive revolution? Well, it fundamentally changed psychology. And when you put its timing into a historical context, it's really, really startling just how young this science is.
First, and this is really important, the revolution didn't just throw behaviorism in the trash. Cognitive psychology absolutely kept the behaviorists' focus on rigor, using carefully controlled stimuli and measuring outputs precisely. What it did was build an information processing bridge to connect the two. It tried to explain the mental journey that happens between the stimulus and the response.
But this is the part that just blows my mind. The cognitive revolution really gets going in the 50s and 60s. The very first textbook that officially defined the field, called cognitive psychology, wasn't published until 1967. And just 2 years later, in 1969, we landed on the moon.
Just let that sink in for a second. Our science of sending human beings to another world was already mature enough to actually do it. And at that exact same time, our scientific attempt to understand the human mind, well, it was basically a toddler. It was just being born.
So I'll leave you with this question to think about. We mastered the rocket science to escape our own planet's gravity before we even had a formal scientific framework for understanding the 3-pound universe inside our own skulls. What does that incredible fact tell us about the complexity, the challenge, and maybe the future of exploring what might just be science's true final frontier?